When looking at a function, we can look at any point on our function and determine the tangent to it. What is a tangent? Well, it's a straight line that has the slope equal to the rate of change of the function at that point. So, if we choose a point of our function, let's say at this point here, our tangent would be a straight line passing through that point equal to the rate of change in our original function. If we choose another point, let's say over here, and we did the tangent for this, it would have a slope equal to the rate of change at this point. So how do we find the equation for the tangent line at a point? Well, there are 4 steps that will give us the equation. Step 1 is to find the x and the y components. You may be given them, but you need both of them to find the tangent line at a point. Step 2 is to find the derivative of your original function. Step 3 is to use your initial value of x and put it into the calculated derivative that you did for step 2. Step 4 is to put these values into our straight line equation. Where now we're using y into our equation, x into our equation, and we're putting our derivative, which is the slope of the line at this point. And this will give us the equation for the tangent at the point. Now let's look at an example for this. So, given the equation y equals 4x squared plus 2x at the point 220. In this situation, we have both the x and the y components. However, if we did not have that, we would put our x value back into our original function and solve for y. So moving on to step 2, we need to calculate the derivative of the function, which is going to equal 8x plus 2. Now that we have the derivative, we can solve this derivative and our condition of x equals 2, which would give us $18. Now we just need to put this into our equation for a straight line. Grabbing these values from the ones that we've been provided and the ones that we have calculated, we get y minus 20 equals 18 outside of x minus 2. However, we can simplify this by going y minus 20 equals 18x minus 36. Now just moving this up over here, we can simplify this again to be y equals 18x minus 36 plus 20, which y equals 18x minus 16. This is our equation for the tangent at the point 220.